Hi there. So, this set of lecture series, we're looking at data visualization project. All right. And what needs to be done here is that um, some set of data is provided to us, right? And based on the instructions given, we need to go ahead and and write some code and output a graph at the end. All right. So the most important thing to understand here is to basically look at the files that's available. So you will see part of this project, there is three files. One is this to record 2308.dat, and then the other one is 338.dat, and then there's another one. There's nothing different with these files. The files contains a similar kind of numbers. All right. So and these are just input. When you run your code, each of these files would be included as an input, and based on the numbers they provide, right, your algorithm is going to read all those numbers and follow the instructions and output, graph at the end. So now I do have this, on my, well, I did have it, but what happened? All right, so I'm going to run this, and I want to show you what the final output is going to be, right? So the important thing to remember is that you want to keep the three files in the same folder. And since most of you may be doing this on Codio, then you may not have to. You can skip this step. But I like copying the code, or the files and code over and doing it on IDLE. It makes it so much easier for me to code. But either way, if you're doing this on Codio, then you don't have to worry about, because all of these would be in the same folder. But if you're doing it on IDLE, then you want to make sure everything's in the same folder. All right, so I want to show you the output, right? I'm going to just run that code, hit here, put right here, right? That code right here, that code. Right, these are some debug stuff that I got. You can ignore this because I'll be using this later when I discuss the project. So you see what happened, right? These are the files that I had before. All right, this is the code that I'll be writing on, and this is the code that I'm I'm running, and these are the input files. And what it did, it went ahead and it created these other 6 files, right? So for each of the input, it will create 2 output files, right? And you see this is 3388 right there. And then, the other one is 2308. It created 2 output files in that manner. And the other one, even though the name is long, such as that, you don't get too worried about it. It's just the same thing. All right. Not the same thing, but it's an input file, right? So in the output, let me just open this output right here, and I want to show you. So in the output, right, one of the outputs will have some data like that. For each pulse, it will tell you where it's starting, right? And some other information we'll discuss later. And then the other cool thing it will create is this PDF. I'm not sure how PDF is going to show up on Codio, but if you do have problem running this PDF create on Codio, you can comment it out, right? Or test it out on your IDLE just to show that you've been able to implement it. That's the reason I like it here. So in the PDF, it will create the 2 graphs, all right, that will show the initial, the raw data graph, and then the smooth data graph. So the output needs to be in that format. One would have a PDF with two graphs on it, and the other one would have a text file with some data on it. And you will do that for each of the input. Remember, there's 3 input files here, all right? All right, let's see what the input file says. Okay, input file, and let's just open one of them. And this has a whole bunch of numbers, right? A whole bunch of some negative numbers, some positive numbers, close to 4,000, maybe 3,500 numbers. Okay, and these are our input. Each file is an input. So the idea is this. As far as the project goes, the project here says, the project is based on actual work done for the Department of Homeland Security. And, the goal is to detect the presence of dangerous materials, through some kind of scanning device. So all of these numbers that you see are result of those scanning devices. your goal is to find out where the spikes are. All right, you see how in the small chart here, it starts at horizontal pretty much, right? And when it reaches to about 1,000, there's a spike, right? And that is what you need to figure out based on the data provided, right? So that's just you take the data and you output a two chart. One chart would be the chart based on the original data, and the other one would be based on the smooth data. Okay, so now it says here the raw data is quite jagged, right? And so you have to kind of polish it up, right? Kind of smooth it. And there's a formula that's given that we'll be using on how to go about smoothing this data. So, right. So what you're going to do here is that, so it says here that, the filter, you will write a code, a function that will be maybe called smooth, and that will start looking at the fourth entry, right? It will start fourth entry because you're supposed to look at fourth entry, and then according to the formula here, see yi minus 3 plus 2yi minus 2 plus 3yi. So whatever your position is, all right, that is I. And when you do I minus 3, that means you have to be, you have to be on the fourth position to be able to do I minus 3, right? And then, or you do, or even doing I plus 4 too, you have to be careful when you reach the very end, because if you add the very end character, a very, very last number, you cannot do I three times I plus 1 or I plus 2 or I plus 3, because that would be outside of the bounds. So that's why you have to remember that when you're starting this formula, right, you are basically starting at the fourth entry and going to the fourth from the last, ending at the fourth from the last position. So, right, so you will apply the smooth formula, which will take all the data, and based on that, it will average it out, kind of thing. So once you have done that, right, what you got to do, you have to write another function that will look for the pulse. All right, and let me go down here, pulse. So that will look for a pulse, and pulse is it is kind of tricky to kind of. I think the most difficult part of this project is visualizing what the pulse is going to be. So the way we detect pulse, remember when it says y is basically each value, right? That's y0, that's y1, that's y2, that's y3, and if you say yi, and if I said I is 17, that means that value. Then if I say yi minus 1, that'd be that one, right? yi minus 2 would be that one, because my yi was 17, right? So that's what it's referring to when you see I here. I is basically an index anywhere in this in this list of data. And in yi plus 2 would be 2 numbers forward that position. Okay, so here, how do we look for pulse? Pulse is basically you compare. You have, of course, you have a loop. You compare a number at an index with the two numbers in the front, right? So I plus and you will subtract them. So basically, what it means is that if your index is 14 right here, you compare 14 with what's at 20. I mean 16, right? That 14 compare with index 16, and you subtract them, and if they are greater than 100, because 100 is the voltage threshold, that means there's a pulse. All right, so that you have to remember that index, and then what you got to do is that you'll have to skip all those numbers based on this other. This is another difficult, not difficult, but kind of tricky piece you have to put in your code. How do you, once you find a pulse, finding a pulse is easy, right? You gotta skip all the next numbers based on this logic. So after finding a pulse start position, advance through the data starting at y plus 2 until the sample starts to decrease before looking for the next pulse. So if you look at my output here, all right, I have all the raw data, right? And this is not starting at, this is from a from a position in the array to some other position, right? It's not the full data, because full data is 3,000 something numbers. So that's my raw data, and then I smoothed it out, right? You see, at that particular position, that is changed to -27. That was -40. They changed to -29, and so forth. So this is all smooth data based on the formula that's given, right? And like I said, this array that I'm printing is not starting at position 0. It's starting at like 1,000, index 1,000 something, because I want to show you the the pulse. How did the pulse come about? Okay, so when I run my program, the pulse, we found out that the pulse starts at position 1020. So when you run it, this is the answer you're supposed to get to. You're supposed to get, because everybody's running the same input, right? Your pulses should be these values. The reason I'm showing you the answers is because I want you to be able to write code and test your program and say, okay, my answers meets what the professor was showing me. So that'll make sense. Okay. So how did we get these numbers? The smooth numbers, and that is based on basically, you loop from the the fourth element of the array right to the end, -4, right? And you apply this formula here, divide by 15, and then you replace whatever answer you get, you replace the value. So -32 was replaced with -27, right? -40 was replaced with -29, and -36 was replaced with this because of that smooth formula. Right. So how do we find out the pulse? So you see, there's a formula for pulse, right? And the formula is that the formula for pulse is if I plus 2, that means 2 positions ahead of me minus my current value, if that is greater than 100, right? So you watch here. If I'm on 24, 2 positions ahead would be 16, right? And 16 minus 24 is not greater than 100. So you're going to keep on going that way until you reach maybe 20, until you reach 40, right? 40. And actually, I'm looking at the wrong one. I should look at this. I'm sorry, the smooth data, right? So I'm going to reach at 26, okay? Because each time I'm looking two positions forward. So I'm going to look at, 138 subtract 26. I hope I'm doing the proper subtraction because it's a negative number. Anyways, if I do that, right, the answer is going to be more than 100. Then I know that's my pulse. So I'm going to save that value. I'm going to save that index, and I believe that index is 1028, right? Then once I got my pulse, I need to skip all of these, right? I need to skip all of these to find the next rise. And the way you're going to do that is you keep on looping forward, right? Advance through the data, starting at I+2 until the sample starts to decrease. So I was here. I'm going to keep advancing until my numbers start to decrease. So advancing right here, there's a decrease right here, right? Then I'm going to start looking for pulse from right here. So all of these would be, I will not look for a pulse in there anymore because that's all the rise. Then I'm going to start looking pulse here again. Okay, so it's kind of tricky. Not tricky, but so that's the idea. Hopefully this gives you some ideas of what to do and how to run it. All right. So some other instructions here. Okay, I'm going to put it here, and I'm going to walk you through some code, and hopefully, you folks that'd be helpful to you. All right. So this I don't need that at 2, and now where's my other window? Here, the back. I think the important thing in here is to understand that do each pieces, right? And you see what I've previously when I was working on them, that's the output of my first. I'm reading the raw data, and I'm checking my smooth data. Then I'm checking my pulses, right, and stuff and things like that. Do it in small pieces. Make sure that each piece works together. All right. So I'm going to help you here. In order to start, you need to import some things. Import. I think that's called glob. As in global. It's not global. It's got nothing to do with global. I think it's called glob, and I'm going to tell you why in a minute why we use it. That is a module that helps you match. It's almost like a Unix module. It's kind of similar to Unix module. It helps you match file name in this case, right? Because you got all the 3 input files is going to look for those in when it writes the, when it starts it. So I'm going to show you right now what it does. So what we're going to do it the proper way, define main, right? And do it here. And then I'm going to put the other code. Now, this means that, hey, every time you are running your code, right, as I'm doing right now, Python knows that is the main, right? That is the main, it gives it the main function. So basically, it knows that I'm the developer and I'm running it, I'm running it myself. So that is why you normally check for this. You will see me when I'm writing code for like tutorials. I hardly put that kind of code in there, but it's good to put it, because that means that if you share the code with somebody, which as a homework you shouldn't, but if you wrote a code and you needed to give it to somebody, then that check will protect your code from running to a code that individual has. All right, so main, and then in the main, all right, so we're going to say for file name, file name in global, right? And we are looking for everything.det. Okay, so that's the only place this thing is used. All right, and basically looks in your folder and looks at the 3 .det files, and for each one of those, it's going to call the analyze function, right? Okay, and then now we don't have analyze function, define analyze. All right, analyze, and that's going to take file name. And I can put pass here. Pass means, hey, I'm going to code a little bit later. I'm working on something different, right? Normally it will give me an error and say, hey, fix this. Okay, let's just try and see what happens if it gives me errors or something like that. Okay, nothing here. Right? So now, if you look at the main thing that you need to do, right, I think the proper thing we got to do is to copy the pseudocode. So I'm going to copy the pseudocode, and I'm going to put it right here. All right, and you just go ahead and do one by one, because the rubric for this also is very similar. Have that one, create some space here. All right, so here it says, take out the pass. Read the data into an array of integers using numpy.load. And numpy.load is really cool things, right? And what it does is that, simple here, you can, let's just have an array, right? That is an array. It's a numpy array. Python doesn't have an array, but numpy has it. np.load txt. You can use load txt, and you can provide the file name here, right? And also you can put the d type, data type. And in the past, I have used, integer, and I think that I2 represents integer. You can also put int here. Sometimes I've had problem when I put int here, but I2 I think does work. So that line of code basically would give you the raw data. So how do we go about checking if that is correct, right? And what I've done here, I did something really cool, was I created another function called define print array, right? And I put a tag here, and then this is not required, but this is my debug stuff. Really important, I think so. I'm going to put data, right? And then basically you can do something like for I in range. Let's just say from, I'm going to put 20 here, right? No comma, 20, print. Okay, and then also I'm going to put here print right. Sometimes students come to me, hey, professor, I'm stuck here. I'm like, I was looking at a code the other day. There was not a single debug statement. I'm like, how are you even telling me that there's a problem, right? You have to follow the flow of your code. It's called incremental programming. And this would be just, by itself, just like a new line. All right. So we want to see, just want to see if the print array worked okay, right? If our raw data has been read in properly, right? Raw data. Okay, run this one. I should see some kind of NP is, NP is not defined, right? That means I need to go ahead and import. Let's just do the import now. I'm going to tell you what import you need. You need import numpy as NP, right? And also you need another import, the matplot library, matplotlib. What should we? .pyplot. Pyplot is the one that is a component that we need to use to plot the graph. Very cool. The whole thing is not. Oh, I see. Raw data, right? I wanna put a tag here because that will help me kind of follow and make sure that I'm I'm checking the flow of my code, right? So you see, it printed. When I'm printing, I need something was wrong. Data. Right now, it's opening the 3 files, and it's reading it's reading the data in the file, and it's converting it to putting it in an array. So if I bring this over, just double checking if everything's okay. So watch the maybe it's reading this one first. It's starting at a -20. Actually, the printout is reading this one first. Well, that one first with a 0. So you see that the first line on the bottom of on the left right here, it starts at 0, 36, 36, 48. Those numbers kind of match here. So at least visually, I can confirm that my numpy.load text is working properly, right? I can visually confirm right there. All right, so now you got that. Then you have to write this other function that will smooth the data, right? That will smooth the data, and so generate smooth data into another array of So generate smooth data into another array of integers. So what you want to do, right? Oh, what happened? That's funny. I pressed some button and just locked my screen out. All right. So here you want to create another function called, let's just call it smooth. Takes in data, right? So a couple of things you got to do, right? It says here, generate smooth data into another array of integers. So here you can create a copy, right? And how do you create a copy? You can say, I'm going to say data 1 is equals to s data is equals to data dot copy. Easy as that. So that basically creates a copy of data, right? And then you have to write this code, right? That will basically take. So I'm going to give you some pseudocode here to do. Right? You basically use a use for loop. Right? The range would be 3 to length -3. All right, so that'd be the length. And then so in your for loop, right, you got to use, and it's pretty cool because let's just say that was your for loop, you're going to say s data, right? You're going to put if I was in your for loop, I mean, if you use the letter I, you will say something like right, that would be divided by 15, and that formula from the your right, that formula will come here. So what is yi, right? Yi basically is, right? No, actually it's yi -3, remember? So that would be s data right? Not S data. I'm sorry, data, right? Data, and here you're going to put I minus 3 and so forth, right? And then here you got, 2i, 2ii. So you'll have to figure this out, right? Anyways, you have to figure that out. And then when you're done, you're basically returning S data, right? So this is a big to-do for you. It's not correct as the way I've written, right? I don't think I need it because I already have 15 here. Anyways, so when you're done with this loop here, that S data, all right, that should basically be that. I mean, not exactly the same thing because the positions are different, but it should convert, if you got a minus 32, it can convert to minus 27. I mean, based on the position you got, you may get something different. So that is what it's going to do. All right. So in order to test it out, okay, so that's once you got the the smooth data. So here you're going to say something like smooth data, right? So now you got the smooth data. So that is good. Now we need to find the pulse. All right, we need to find the pulse, and you can simply have a array here, pulse, all right, like that. And so I'm going to give you the while loop, right? The while I is less than the length of smooth data minus 2, right? Because you remember, you're comparing current position with 2 ahead of it, right? So that's why you want to compare, have a minus 2 here, because when you reach the end, you don't want to, there's nothing to forward. All right. So in that loop, you're going to do I'm going to put a to do here for you, right? You will basically, right, compare for over, over 100. I think 100 is the VT. It's called VT, right? Read the instructions and you will see what I'm talking about, right? Compare for over 100, and then, right, compare for over 100, and if you find it, then you will do pulses dot append. You're going to put that I in there. All right, put that I in there, and then you have to, this is the tricky part, right? You will have to figure out some code here, another to do for you guys, right? You're going to skip this rise. So you're going to keep skipping until you start to see, the data coming, data decreasing, and the discussion on that is right here. It says, so detect a pulse by looking for rise. And how do you look for rise? You take the 2 values, I mean the 2 positions in front, and minus with the current position. If that is over 100, then there's a rise, and you're gonna put the index in the pulse array, right? And then after finding the pulse start position, you will advance through the data, starting at the second position and keep on going, keep on moving forward until the sample starts to decrease before looking for the next pulse, right? So you're going to keep on going until you start to decrease. All right. So that is the one thing you got to do, and then after that, so this is computing, right here, computing the data. Move that. Oh, no. So then, okay, so that is, once that is done, right, you got the pulse, and in our cases, you'll have 3 of them, right? So then you have to compute the area of a pulse, starting at the beginning of the pulse, and then add the next 50. Remember, 50 raw Y values together. Remember, you're not adding the smooth values, you're adding the raw values. All right. So that is a little tricky thing that you have to be a little careful about. Okay. And then if the next pulse starts in less than 50, values stop adding to that point. So what that means is that, right, once you got, once you find the pulse, then you need to find the area. And the way you're going to find area is basically you take the next 50 raw values and add them together. Okay. However, while you're looking at the next 50 raw values, and in between there, if the next pulse starts at one of the indexes, then you will stop right there. All right. You stop adding to that point and not including that point. So that is basically your area. Okay. And so that is that. And then once you have those data, so the compute area, all right, that will be part of your output. Let me see my output. No, not this one. I had a folder here. Out, right? All right, you see that? So the first pulse in this file was at index 1020, all right? And 1020, and that is the area of the pulse. So here, you'll basically that is what you need to save to that file, the dat file here, right? For each file, the area for each pulse appears in parentheses after its start position, right? The data tells us that one pulse one, sum the voltages at raw data position 1019 through 1029 in the array, right? And the total is 340. So this kind of explains you of what, how you can use to measure the correctness of the area. And in our case, for that file 3388, that is the answer, and you want to make sure that your code produces that, right? That is the answer. So okay, so that is that. Let me move this away too. All right, so that will, it's not, I don't think it's too tricky. I think all right. So this part, you guys got a big to do. I mean, spend some time, go to tutorial or tutoring sessions and whatnot, and see if you can, get some. And the whole thing, looking at the logic, the whole thing you're doing is that you basically, well, let me give you some ideas here. So you basically gonna, for each pulse, how many pulses are there? Maybe 2 or 3, not too many, right? To each pulse, you're gonna get the start position. And how do we get the start position? The start position is right there. It's sitting in it. Whatever value is in the array is the start position, right? And then what is the width here? It says 50, right? So that means we're gonna go ahead and get the start position, and you will basically sum, and you need some other code here, but I'm just telling you something. You will sum the raw data, right, from start position to start position plus, I think it's 50, right? 50. All right. But here you need to check. You need to check if you need to check for this thing. You need to check for this thing. Right, you got to check for this thing right here. So check for this thing, and then figure out what the end position is. I'm going to put end position here, right? Figure out what the end position is, and then you can do the summing. So once you've done that, right, you want to go ahead and graph, do the graphing, and in the graphing, basically, this is it's not too difficult. I don't think it's too difficult, And, you know, as you are doing this, right, once you're doing that, you have to also save information to a, I think the dot out file. And in order to test, right, you want to have that as your information here, right, in order to test. This is just to make sure once you get a number of that sort, once you get an output that matches these, that means your calculation is correct. All right. Once you get, you know, that number, that means your calculation is correct, and that number's calculation is correct. All right. So how do we graph this thing out? Graphing is not bad at all. And basically, so in Python, sometimes you will see, you know, that being used, or you can even put a variable here. I'm going to just put a var, you know, just a variable, comma. I'm going to put axis, right? You can say plt as in plot. Dot subplot. Subplots is pretty cool. It allows you to create like multiple, you know, multiple graphs kind of thing, and rows, and you can put a default here as 2. Then axis. Actually, instead of using that, because I'm not going to be using it, the proper way to do is to put underscore like that. Underscore means, hey, whatever value comes in, I don't really care. I'm not going to use it, right? Just forget about it, right? That's what it means. Plot, and you can put the because you need to put the raw data, right? The raw data, and put maybe like a line width equals to 0.2. All right, and then that's on one axis, and then you're going to have another one. See, because what happens is that code, it creates 2 graphs, right? And those 2 graphs are kept in those variables, right? That is for graph number 1, and then this is for graph number 2. Okay, dot plot, and you're plotting the smooth data here, right? Smooth. What is it called? Smooth data. I think it's called smooth data. Anyways, if I'm wrong here, then you guys can you know, you guys can fix it already. Dot 3. All right. And then you do plt plot dot save and put a file name, right? I'm going to tell you this code here. That simply means take the file name from last 3, right? Take the file name, take out the last 3 characters in there, and replace it with PDF, right? So file name, because initially our file name had a .dat in it, DAT. This means take it out and add a PDF. All right, so that is it. This will allow you to create a graph. You know, I don't think I'm missing anything here. You know, you may have to set the title and all that, but you guys can do that. So the big part of this project is basically creating the pulse. All right, creating the pulse, and then you know, creating the area calculating the area for the pulse. And the way you're going to do that is, you know, spend a lot of time just understanding the question, and also looking at the data, right? You know, being able to print it out, and, you know, in this manner, calculate it, right? You know, it's really good. See what I was doing, right? That's what I did. So this, I believe this is position, I believe 115. I believe that is, no, I'm sorry, right here. I believe this is at 115. So 116, 117, 118, 119, 120, right? 120. And you can see, because I'm comparing 120 with the second one ahead of it, that's a rise, right? So that's why that's my index. 120 is index right here. And then I'm going to keep on going, compare that with that, is still rising, still rising, still rising, still rising, still rising, still rising. There, it starts to come down. All right, start to come down. So I will skip all of these. When it starts to come down, then I'm going to compare again. Hey, when is my next rise, right? So I'm going to compare this with this. I don't see 100 difference. But when it comes down 56, 546 here, that's probably my next rise, right? And that probably is 1035. Index 1035, right? And so forth, moving forward. All right. So that is that. And I want to, okay, so then in calculating the area, right, you're going to look for the same index 1024 in the raw data. I'm not sure where it's going to be. It's probably going to be right here, right? And then you go ahead and calculate or add the next 50 values, right? Next 50 values only if the next rise is not within the 50 values. But here the next rise is at 135. So you're probably going to calculate, you probably will calculate, so 15, 16, 17, 18, 19, 20, right? I'm right here. And I believe you will add all of these, and I believe the next rise is right here, right? So you're going to add all of those together. All right, so how much is going to be? I'm not sure. 3388, right? 3388. Anyways, yeah, figure it out, right? Run it and figure out. But it's really good to look at data. I mean, anytime you are writing code that manipulates data, you want to look at data and understand how your code is going through each one. How the answers, how is it 1020, right? How is it how is it this data? All right. So what I was doing, I copied, the raw data from 3308, right, and the smooth data from both of them into an Excel sheet. Hopefully this fits here, right? You guys can see that. And I tried to, because the rise starts at position 120, and I tried to add all the raw values till like 135, and I got 26660, which is not correct, which doesn't match, the one number that I was talking about. However, so initially, my code produced 43272, and there's probably a problem. So, initially, how I said that may be the number that may not be the correct number. However, I looked at the other one, 2308 input, right, and that one, when I copied the raw data on an Excel sheet, and I started at position 19 right there, 19 to like 31, I believe, or 30, whatever the ending point is, and my answers actually came to right. So that is a way you could double check. So in order to double check if your answers are correct, right, you want to look at those values from 2308 file, right? Make sure pulse 1 starts here, and that is the answer. So that is correct. I'm not sure about the other one. I'll have to double check a little bit more and see why it's not, why it's not. Maybe I'm missing something with my calculation, but still, at least one of them is correct. So I believe both of them are correct. Maybe just my calculation is not probably, maybe my Excel sheet needs to have something else in there. Okay, so some code right here, some here. Hopefully this will help you, and like I said, each understand the logic that is being asked in the assignment, and then code each piece, right? Each piece. Look at the numbers, calculate the numbers, and then match those numbers with your code and see why is it not doing what it's supposed to do. Anyways, thank you then.